Let us look at proposition number 10 of book 12 of Euclid's Elements. The proposition says that any cone is a third part of the cylinder with the same base and the same height. Okay, let's see how we can prove this. Let a cone and cylinder have same base, that is a circle ABCD, and the same height. What the proposition is saying is that the volume of a cone is 3 times the volume of the cylinder. We are going to use proof by contradiction. So, if not, then cylinder is not equal to 3 times the cone, and which means either it is less or it is more. So again, we'll have to take it up case by case. So if possible, let the cylinder be greater than 3 times the cone. Now, inscribe the square ABCD in the circle ABCD. Of course, I've chosen these points ABCD in such a way that on these points itself, we can build a square. That means the square ABCD is greater than half of the circle ABCD. Can we say that? Because if we draw a square which circumscribes the circle, then we know that the circumscribed square is twice the inscribed square, and the circle lies between this circumscribed square and the inscribed square. So which means that the square ABCD, inscribed square, is greater than half of the circle ABCD. Now from the square ABCD, set up a prism of equal height to cylinder. So let's set up the prism. So we can say now that the prism is greater than half of the cylinder. Bisect the circumferences AB, BC, CD, and AD. So let's do that. Join the points. Now the triangle AEB, triangle BFC, triangle CGD, and triangle DHA are each greater than half of the segment of the circle about them. And how can we prove that? We have already seen this type of situation in one of our previous propositions. Basically, we build or construct a parallelogram on AB, and the opposite being the tangent to the circle at E. Then that parallelogram is twice the triangle, and the circle is again between these two. So between the parallelogram and the triangle. So we can say that these triangles are each greater than half of the segment of the circle about them. And on each of these triangles, set up prisms with same height as the cylinder. So let's do that. Now, each of the prisms are going to be greater than the segments of the cylinders about them. What we talked about in terms of bases, that is segment of the circle and the triangle, applies to the solids on them. So each of the prisms is greater than the segments of the cylinder about them. Now repeat bisecting the circumference, prism, etc. till the remainder of the segments of the cylinder is less than cylinder minus 3 times the cone. Because remember, we assume that cylinder is greater than 3 times the cone. So if we keep repeating this process, at some point, the segments of the cylinder will become less than the difference between the cylinder and the cone. To avoid overcomplicating this diagram, let's say we have reached that stage. Let these segments be AE, EB, BF, FC, and so on. So the remainder, the prism with polygonal base and the same height as that of the cylinder, is greater than 3 times the cone. Prism with polygonal base AE, BF, CG, DH and the same height as that of the cylinder is 3 times the pyramid with polygonal base AE, BF, CG, DH. and the same vertex as that of the cone. So let's bring in this pyramid. We already know that prisms and pyramids, they are to each other as their bases. And we know that prism with a polygonal base is 3 times a pyramid with the same base and same height. So the pyramid with the polygonal base A, B, F, C, G, D, H and the same vertex as that of the cone is greater than cone with circular base ABCD, because here we said it is greater than 3 times the cone. So here also it will be greater than cone with circular base ABC. But it is also less. Why? Because the pyramid is enclosed in the cone. So it is greater than the cone. It is also less than the cone because of enclosure. So we have reached a contradiction. So therefore, cylinder is not greater than 3 times the cone. So we have disproved our first case where we assume that the cylinder is greater than 3 times the cone. Let's look at the other case. If possible, let cylinder be less than 3 times the cone. So inversely, we can say cone is greater than 1/3 of the cylinder. Inscribe the square ABCD in the circle ABCD. So let's do that. Now the square ABCD is going to be greater than the half of the circle ABCD. Again, we can prove this statement by drawing a circumscribed square, and that we have already seen in the previous case, so I'll not get into that. Now set up from the square ABCD a pyramid with the same vertex as the cone. Okay, so this is the pyramid. Now the pyramid setup is going to be greater than half of the cone. I set the circumferences AB, BC, CD and AD at various points and join them. So let's do that. So we get a polygonal figure. Each of these triangles, triangle AEB, BFC, CGD and DHA, are going to be greater than half of that segment of the circle, which is about it. And on each of the triangles, set pyramids up with the same vertex as the cone. So on these triangles, we set up a pyramid so that we end up with pyramid on a polygonal base. Each of the pyramid setup is going to be greater than half of that segment of the cone about it. Again, we repeat bisecting the circumference, setting up the pyramids, etc., till the remainder of the segments of the cone is less than the difference between the cone and 1/3 of the cylinder. For simplicity's sake, let the remainder be these segments itself. The pyramid with the polygonal base AEBFCGDH and the same vertex as that of the cone is greater than 1/3 of the cylinder. The pyramid with the polygonal base and the same vertex as that of the cone is equal to 1/3 of the prism with the polygonal base AEBFCGDH and the same height as that of the cylinder. So if we set up a prism with the polygonal base, so let's do that. Prism with the polygonal base A, B, F, C, G, D, H and the same height as that of the cylinder is greater than the cylinder with the circular base ABCD. But it is also less since the pyramid is enclosed in the cone. So we have reached a contradiction. So therefore, cylinder is not less than 3 times the cone, which was our assumption when we started. So cylinder is not less than, cylinder is not greater than 3 times the cone, which means cylinder is 3 times the cone. So that is proposition number 10 of book 12 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.